Hey class, so in this video I'm going to take a look at summations and how to deal with indices of summations and just the math that's involved in those things. So the first thing that we're looking at here is so let's just do a simple summation. So let's say I've got a pretty basic data set. I'm just going to 1, 4, 6, 2, and I don't know, 5, whatever. So let's say that that's my data set, okay? And you know, so your summation looks like, so you have the sum of little xi's and you know, so, you know, we're summing the i's and we can sum, there's 1, 2, 3, 4, 5 numbers in my data set, so we're summing those 5 things. You really don't need to know what sigma is and all the little teeny details there are. Like basically anytime you see the sigma sign, it just means the sum. You're just adding up everything that you have. This xi is referencing and saying, hey, go to your data set. We're going to add up all the little things that are in there. Okay, so the sigma xi is just telling you, hey, we just want to add up the things that are in the data set. And so for us, right, this is the equivalent of 1 plus 4 plus 6 plus 2 plus 5. And so what? That would be 10, 11, 13, 18, right? And so like for a simple summation, that's all we're doing, okay? Sometimes there may be like extra operators. Okay, so for example, let's say that we have this sum, again, of xi, but then let's say that it also wants us to divide that by 2. So there's a couple of ways of looking at this, right? We could say, okay, this is really the sum of 1 divided by 2 plus 4 divided by 2 plus 6 divided by 2 plus 2 divided by 2 plus 5 divided by 2. Right? I go to my xi's, run up to my data set, I grab all my values, and I'm just dividing them all by 2 and then adding them all together. And if you know how to add fractions, right? Looking at this, the denominators are all, so this is nice because the denominators are all the same, and so it's just going to be the sum of everything on top. I already know that's 18, then divided by 2, so this is 9. Okay, or another way to look at this is, you know, using associative properties in mathematics. You can take this plus 2 and you can pull it out front, and so it's 1/2 times the sum of the xi's, and you can say, oh, well, I know that that's 18, so it's 1/2 of 18, and I get 9 again, which is good because that's the answer that I had before. So that's how to do these, right? I recommend, for a scenario like this, where you're either dividing or just doing a basic multiplication, because of the associative property of math, I know that I can take this and I can run up here and add these all up together really simply and then divide by or multiply by the number that I have down there. Another thing that they may do is you may see something like this where they say, okay, let's do the sum of, and then they do a parenthesis of the xi's plus 2. And now for this, I can't just say, you might want to say, oh, well, this is just going to equal the sum of xi plus 2. And this is 18 plus 2 is 20. Nope, right? That's not how this works. You can't do the same thing with the division that you did here. So again, let me write this out. So the sum of xi's plus 2. So what they're wanting you to do here is this is really going to be equal to 1 plus 2 plus 4 plus 2 plus 6 plus 2, and so on. And so then you'd have to go in here. So then this is 3 plus 6 plus 8 plus 4 plus 7, right, is what it would end up being as you went on. And then you would add all these up and get some number, and that would be the sum. Okay? So that looks just a little bit different than what we did before with the division, but still not like too much of a stretch. Just be careful if you're... I like to write these things out by hand because then I can keep track of all the steps and make sure that I'm not making a mistake. If you run everything and keep it inside of a calculator, you run the risk of making an error. Now, the reason why this is all important and the reason why we're looking at this is because we're leading up to a topic called standard deviation. And with standard deviations, when you're calculating the standard deviation, it's it's the square root of the sum of the xi's minus the average, or the mean, quantity squared, divided by n minus 1. So there's a lot of stuff going on in there to calculate the standard deviation. But what, and again, that's coming a little bit later, but what we're interested in is looking at just this bit, right? What if you had something like this? So if you had the sum of the xi's minus the average quantity squared. With this, you really need to be careful and take things in parts. So the first thing, right, I know that this is going to be equal to 1 minus the average of the set, which would be, well, unfortunately for us, it's kind of an awkward number, right? It's 18/5 quantity squared plus, and then it would be 4 minus 18/5 quantity squared plus, do you see the pattern? I'm 6, I'm just pulling, now it's just minus 18/5 quantity squared. And then I could get my calculator out and calculate each of these things. And they're going to be ugly little decimals because of the 18/5. And then you would square that, which would make the decimal even worse. But if we had cleaner numbers, then it'd be a little bit easier to do by hand. But I think that you kind of see, right, whatever this number is, then you would add it to this number, and then add it to whatever that number is, and eventually you'd end up with some total at the end after adding all the little parts together. But the point of it is that when you see this summation sign, it's just asking you to do a sum, and you want to look at and identify, okay, well, what numbers am I going to plug into the sum? The average is a constant, right? That's the same. If you look, that's the same in each case. The average is always there, and then this square is always there. That's not changing. So the only thing that is changing, the number that I'm changing every time, is this one, and you can see that those come from the data. And then after I do my math, get an answer. Right, after I crunch all that out, then I just add those up, right? But sigma in the summation sign is all about just doing a little bit of addition. So if you have any extra questions about this and how it works, please shoot me a note in Canvas or a message here, and have a great week. Thanks, everybody.